Welcome to episode 21 in the mathsonlinetuition.com videos, where we're going through the C2 book. We're on chapter 5, so we are making good progress. The binomial expansion. What is binomial expansion? So in this chapter we will discuss these three key points, so make sure that you read them to understand and appreciate what we will be going through, because as you can see here, we will revisit this technique in core 4 when you will expand expressions when n is not a positive integer. In the meantime, see if you can solve the problem below. So what this means that n here in this particular case will always be positive, so you won't have to deal with any negatives or any fractions of that nature when it comes to conversion. So the binomial expansion. Let's start off with Pascal's triangle, okay, and explain how we can appreciate this particular question. So consider the following. You can see that every time so this, for example, is a simple bracket to the power of 1. Okay, this here would give us a to the power of 2, okay, and this is to the power of 4, etc. And you can see there that they have expanded it, okay, very simple to appreciate just by looking at the pictures. And then this is what they get for this particular quadratic. Here is cubed, so again all they've done now is expanded it once more, and you can see that just at the cubed it's getting quite lengthy in terms of being able to expand it. So here is a summarized chart, or a triangle, okay, which displays and projects all the finalized expansion and summaries of the different powers of these brackets. Okay, A and B represent terms here, and you'll see how that works later. Now you should also notice that there's a pattern here whereby the number to the left and the number to the right, or vice versa, the number to the right and the number to the left, okay, are added together to give the number which is at the bottom, which is beneath them and in the middle. So to the middle and beneath them, and you can just use this particular diagram here to give you an impression of what I mean. So between them and beneath them, okay, so 3 plus 3 is 6, 10 and 10 is 20, 10 and 5 is 15, 5 and 1 is 6. So you can see that that works throughout the whole triangle here, okay. So use Pascal's triangle to find the expansion of the following. Now if we had this particular question where we were asked this particular question, right? Now it would be pretty lengthy for us to do the following, okay, although it would be correct in an exam, it would be very difficult, alright, and then you'd have to do that, and then same thing with there, and then, you know, it gets pretty messy. And in an exam, if you're asked to use Pascal's triangle, or sometimes not even asked to use Pascal's triangle, but you're given a question, and this could be, for example, this could be 6. Now they don't expect you to go through this particular method, and what they do expect you to do is use Pascal's triangle, okay, and the time that you have in the exam will be evidence of that. So you need to be cautious about how you approach the questions. I think anything greater than cubed, okay, in an exam where you haven't been asked to use Pascal's triangle, I would highly recommend you use Pascal's triangle. So here we have to the power of 3, okay. So how do we start off? So this is our A, and this whole thing here is our B, okay. So we take the coefficients. First thing we do is we take the coefficients, alright. So the coefficients are going to be 1, 3, 3, 1. Where do we get the coefficients from? Right, this is to the power of 3. So if we go up to our triangle here, this is the first line, the second line, this is the third line, this is the fourth line, okay. And the reason why we choose the fourth line is because, remember, we start off with to the power of 0. So you can see that to the power of 3 is the fourth line. I have 1, 3, 3, 1, okay, which corresponds to this here. Okay, so carrying on with the question, now we can appreciate that we have to have, following our example, okay, following x3, let me use a different color, x3, let's write over that, plus, and then we're going to have x2, 2y 1 plus x multiplied by 2y squared plus 1 2y cubed. Okay, now the reason for that, as you can see here, the answer is as follows. The reason for that is the following. If we look back at our triangle here, you'll note that we have this particular pattern going on. Okay, so we had 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed, and we understood from our explanation a few minutes ago why we have the coefficients. Now then we have a represented in this particular situation as x, and b in this particular situation represented as 2y, because the general form is as such, okay, where n is 3 in our particular case. So we substitute it in here. So we have 1, we had x3 plus 3, and we have x squared, and then b, so we have 2y. Then we have plus 3, and so on and so forth. Okay, now the way, or another trick to appreciate, okay, if you're getting your powers correct, is by observing the following. 3 is the highest level of a power we have in this particular question. So when you are working out, okay, your powers, to ensure that you've got it right is to make sure that no term exceeds the power of 3. Here you can see we have 3, 2 and 1 here, which gives us 3. You have 1 here and 2, which gives us 3, and finally you have 3 here. Okay, now another way, okay, of appreciating this is that as a, okay, starts off with the highest power, in our particular case 3, it will decrease by 1 and b will increase by 1. So here you can see, and I'll use a different color to start this explanation. Here you can see, just taking the terms, okay, but omitting the coefficient, just to make this point. We start off with a3, but b is 0, okay, to the power of 0. Then we have a squared, and we have b1, okay. Then we have a1 b squared, and then we have b cubed. So you can see that as we start off with 3, the highest power, okay, this decreases by 1 and this gains a 1. This decreases by another 1 and it gains another 1, until we get back to this point where b now has 3 and a is 0. Okay, we know that anything to the power of 0 is equal to 1, which is why it's denoted as that. Okay, so that explains the question. If you look at b, now you can do a similar thing, but with b you have to be careful and also include the negative. You can't omit the negative. The default of the equation is always as such, okay, a plus. So if you have a negative like here, then you have to incorporate it along with that numerical value, okay, so it has to be included within every b term. And you can see here you have an unknown, okay, but you're given the answer here is 294, so you can just figure out c by rearranging. You have some exercises here to carry out on your own. Now 5.2, you can use combinations and factorial notion to help you expand binomial expressions. For large indices, it's quicker than using Pascal's triangle. Right, so here you can use combinations, okay? And the combinations here are represented with the following. N equals n multiplied by n minus 1 multiplied by n minus 2 multiplied by something, 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 so on and so forth until you get to 1, okay? And this is easy to appreciate. So for example, we had 3 factorial, okay? The answer is going to be, well, n is 3, what's 3 minus 1, 2, what's 3 minus 2, and then you have 1, and you can see that we've already achieved our end. Likewise, if we had another larger number, 10 for example, have 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6, and so on and so forth until we get to 2 multiplied by 1, okay? If you multiply up all these terms together in one shortcut or quick way, you can use the factorial sign, and it's on your calculator. You'll see on your calculator the factorial sign. Suppose you wish to choose any two letters from A, B and C where order does not matter. There are 3 different outcomes. We represent this by 3C2 or 3-2. So if you have 2 values, okay, and you want to, and order does not matter, they can be represented as such, or 3-2, okay, 3 factorial, 2 factorial, 1 factorial. Note that 2 and 1 equal 3, okay, and also note that 3 subtract 3 take away 1 is 2, okay, so just a little triangle for you there. Alright, just to give you an appreciation of what's happening. So this is the total, and obviously these are 2 terms, and this here is 3 minus 1, alright? So the way that you calculate, or the way that you read the following formula is: number of ways of choosing R items from a group of n items is written, okay, and represented as this, or NR, and is calculated by the following. So you have that the number of ways to choose R items from a group of n items. Of course, here R is always going to be less than or equal to n, okay, written as CR or NR, okay, and is calculated by n factorial n minus r factorial r factorial. And you can appreciate, remember what we said earlier on, which is that n, okay, is a total. You have n minus r here and r here, so if you subtract these two, you'll get what's left here, and if you add these two, you'll get what's up top. Okay, just something for you to remember the formula easily. So they give you an example here, 3C2, and you can see how they've worked out. You can use NR to work out the coefficients in the binomial expansion. So this is how you can also rephrase, okay, a binomial expansion in this particular manner. And if you recall, we were discussing about the powers. See n here, so you have n minus 1 and b, n minus 2 and 2. If you add them together, you'll get n, okay? Something for you to note. And then also this is written as follows. So n0 just represents the first term in that line. If we scroll all the way back up to the triangle, so this will be, for example, this will be 1, 2, 3, 4, 5. So you'll have n0, and you'll always represent the first. Then you'll have, for example, n1, and it'll always represent the second. Okay, remember that, I'll give you an example. 2000 to the power of 0 is 1. Everything to the power of 0 is equal to 1, and this is why you have these ones that are along the edges. Okay. Right. And then you have some examples here to follow. So 3 minus 2x to the power of 5. So again, this is our A, and then minus 2x is our B. So we start off with 1, and then we have 5, 1. So remember, here would be 5, 0. Have this invisible 5, 0, and that's 1. Okay, and then remember we have A to the power of n. Okay, B 0 plus, and then 5, 1. Then we have an minus 1, and then b1. Okay, so you can see in this particular situation, b is minus 2. Okay, and then obviously a is, in this particular equation, 3, and then it's to the power of 5, and this is to the power of 4, it's power of 1. Okay, and on and on and on. So it shouldn't be difficult for you to appreciate at this point what you need to do for the rest of them. Okay, and here you can see just another worded question. Okay, very simple, straightforward. All you need to do is just follow the rules above and what you've learnt. Now 5.4 discusses the brackets. You need to be able to expand 1 plus x to the power of n and a plus bx to the power of n using the binomial expansion, right? So here is essentially this, okay, rewritten, and all you need to do now is use the factorial, your appreciation for factorials, your appreciation for how to write out the equation, okay, and expand and simplify. So you can see now that they have used the formula above, okay, and then they've expanded the bottom as well later on. Alright, summarized it, so multiplication, and then there's division. Alright, and they've got the following here. So again, this is just expanding, so the expansion only works for as follows. So take out a common factor, so they've taken out the 2 because you have to have it in the form of 1 plus x. Okay, 1 plus x. Alright, so here the x is equal to x over 2. Okay, but you have to have that 1 here. And then again, they've just essentially used what they know of the question, right, using this particular form, and then they've just multiplied 2 to the power of 6, which was taken out, which was that factor taken out, and then multiplied it at the end. And here we have the mixed questions, which symbolizes the end of this chapter. Here are the summary of key points. So once again, we discussed the Pascals triangle. We spoke about the factorial and what they represent. We spoke about the other ways of resolving it, solving this particular coefficient. We spoke about the formula of the representation of the binomial expansion, 2 of them. Okay, just to give you a variation in how their notation would look like in different books. And then also similarly, we utilized the x being present with the b, and then again we used this particular form in 7 1 plus xn, okay, to illustrate this particular formula, which is also a plausible question that could be asked in this particular form. So there's a variation of ways that you can appreciate the expansion. So that's the end of this video. Thank you very much for listening, and we hope that you join us for our next video. Take care and goodbye.